Okay, let's just get right into it. We all know large language models are incredible, but they have this one giant blind spot, your private data, right? They're trained on the public internet, not your company's internal servers. And the solution everyone's talking about is RAG, or retrieval-augmented generation. It's a fantastic idea, but there is a massive, massive gap between a slick-looking demo and a system that actually works in the real world. And that's exactly what we're going to break down today.
So here's the plan. First, we'll cover the simple, elegant idea behind RAG itself. Then, we're going to get into the messy part, why those clean demos just completely fall apart in the real world. After that, we'll start building. We're going to lay out the entire blueprint for a production-ready system, piece by piece. We'll start with the data, move on to the reasoning engine, and then wrap it all up with the final safety nets that you absolutely have to have.
So, what is RAG really? At its heart, it's a super clever workaround. It's a way to let an LLM answer questions about your specific documents without having to go through the incredibly expensive and time-consuming process of retraining the whole model from scratch.
And the process, it's actually beautiful in its simplicity. It just happens in 3 steps. First, you retrieve the most relevant bits of information from your knowledge base. Second, you augment the user's original question with that information you just found. And finally, you let the LLM generate an answer, but, and this is key, it can only use that new context you just gave it. That's it. Retrieve, augment, generate. Simple.
It seems so straightforward, doesn't it? Almost foolproof. But here's the problem. The moment you take this simple process out of a controlled lab environment and drop it into the chaos of production, that simplicity, well, it can become a huge liability.
And this quote from Google Research, man, it just hits the nail on the head. They've found that getting the wrong information, bad retrieval, is actually worse than getting no information at all. See, when you feed an LLM the wrong context, it doesn't just get confused. No, it hallucinates with even more confidence. And that is the core problem we have to solve. Getting retrieval right is everything.
Okay, so let's dig into that. Why does this breakdown actually happen? What is it about the real world that just shatters the illusion of that perfect demo?
Well, in a demo, everything is pristine. You're using clean, simple text files. You're asking questions you already know the system can handle. Production reality, though, it's a total mess. We're talking about gnarly PDFs, complex tables, multiple versions of the same document floating around, and users who ask vague, rambling questions. The simple model just isn't built for that kind of chaos. Let me give you a concrete example. A user asks, "What's our parental leave policy?" The system finds a chunk of text that perfectly matches those keywords. Awesome, right? The problem? That text is from a policy document from 2019, and it's been updated twice since then. The system has no idea. It just saw a keyword match and went for it.
Or how about this one? Your system is chunking up a document, but it does it poorly, and it splits a key sentence about eligibility requirements right down the middle. So the LLM gets half the information it needs. What does it do? It confidently just makes up the rest, and it's almost always wrong.
And oh, this is a classic. A ton of your most important data is locked away inside a table in a PDF. A simple text extraction tool just turns that beautifully structured information into a completely nonsensical jumble of words and numbers. The system might retrieve this mess, but the context it provides is total garbage, leading to a garbage answer.
And here's the kicker. The most important thing to understand is this. When an LLM gets bad context, it doesn't just throw up its hands and say, "I don't know." It actually becomes more confident. It uses that flawed information as a launchpad to just invent an answer that sounds completely plausible but is totally wrong. And that's way, way more dangerous than a system that just says it doesn't have the answer.
Okay, so we've laid out the problem pretty clearly. Now, how do we fix it? Let's switch gears and start building the solution. This is the full-scale architectural blueprint for a RAG system that is actually robust enough for production.
Now, I know this might look a little complex at first glance, but it's all about building a smarter, more resilient process. It all starts with smart data ingestion. You have to get the data in right. Then you need hybrid data storage to handle it properly. From there, an advanced reasoning engine and multi-agent coordination actually figure out the user's query. But it doesn't stop there. The whole system is wrapped in human thought validation, and finally, rigorous evaluation and testing to make sure everything is working as it should. Let's start right at the beginning with the data itself. This is the absolute foundation of the entire system. Because, you know the saying, garbage in, garbage out. If you get this part wrong, nothing you do later on is going to be able to fix it.
So a real production ingestion pipeline has three crucial stages. First, you have to restructure the raw document. You don't just rip out the text. You parse it to understand the layout, the headings, the paragraphs, the tables. Second, you chunk it intelligently. You split the document along its natural boundaries, not just every 500 characters. And finally, for every single chunk, you create rich metadata, things like summaries, keywords, maybe even a list of questions that chunk could answer. All this extra work makes retrieval so much more accurate down the line.
So where do you put all this beautifully structured data? Well, most demos just use a simple vector store, which is great for searching by general meaning, by the vibe of a query. But in the real world, you need to filter by hard facts, like only show me documents from after this date, or only from this author. That's relational data. A production system uses a hybrid approach. It combines both, so you get the power of that fuzzy semantic search and the precision of a traditional database filter.
Okay, with a solid data foundation in place, we can now look at how a production system actually thinks about and handles a user's query. This is where we move way beyond a simple search bar.
We just talked about hybrid storage, and that leads to hybrid search. A simple vector search is great for understanding the meaning of a query, but it can easily miss specific keywords like product names or error codes. So production systems use a hybrid approach. They combine that semantic vector search with good old-fashioned keyword search to get the best of both worlds, and then they re-rank all the results to find what's most relevant.
And this is where things get really cool. It leads us to a much more advanced idea called agentic RAG. This is the point where the system stops being just a simple search and answer tool and becomes a genuine problem solver. It can actually reason about a query, create a plan, and use multiple tools to figure out the answer.
So how does this reasoning engine actually think? Well, first, a planner agent looks at a complex query, something like, compare our Q3 performance in Europe versus Asia. It breaks that down into smaller steps. Then, it executes those steps. Maybe it runs multiple different searches. Maybe it calls an external API to get sales figures. And finally, it synthesizes all of that gathered information into a single, coherent answer for the user.
But of course, with all this added complexity, there are more chances for things to go wrong. And that is why the final, and maybe most important piece of this whole architecture is a robust safety net. It's there to catch any errors before they ever reach a user. You can think of this as your AI's own internal quality control team. You've got a gatekeeper that checks, hey, did this response actually answer the user's question? You have an auditor that verifies every single fact is grounded in the sources we retrieved, that it's not a hallucination. And then you have a strategist that takes a step back and asks, okay, does this answer even make logical sense in the bigger picture?
Because at the end of the day, if you're not measuring it, you can't improve it. It's that simple. So you need to be constantly evaluating from every angle. For quality, you can actually use other LLMs as judges to rate the answers. For accuracy, you're tracking hard numbers like precision and recall. And for speed and efficiency, you're looking at performance metrics like latency and cost. It's a constant cycle of testing and improving. So, this is what it all boils down to. It's the one question you have to ask yourself. It is incredibly easy to build a RAG system that looks amazing in a controlled demo. But building one that is reliable, accurate, and safe enough to actually perform in the messy, unpredictable reality of a production environment, well, that requires a completely different level of thinking and engineering.